Welcome you all for the next session of digital electronics, where in the previous sessions we have seen the signed numbers, arithmetic operations, along with some combination circuits like adders, decoders, multiplexers, encoders, demux, and the last class session was related to BCD to 7 segment thing. And after BCD to 7 segment, we are pending the topic in our unit 2 is related to parity. Means how a parity is going to act in a digital communication. How a parity plays a key role while sending a data from one point to the other point. Let's see in this session. Now, parity. Now, the basic definition how the parity is used. Parity is used to detect the errors. It detects the single bit errors. Now, parity is used generally to detect whether I am able to receive the information which I received from my receiver is proper, the thing which was transmitted by the transmitter. This parity bit is attached along with my data bits. Now, parity is of two types, that is even parity and the odd parity. I am having one parity as even parity, the other parity is odd parity. Even parity. How a even parity is used while sending data. First, we'll see how a even parity can be represented. Now, even parity bit is 0. And if in given stream of bits, the number of ones are even, then I call it as even parity. Now, if you observe clearly, this is my data. 0110 is my data. Now for this 0110, my number of ones I need to count always, so that if the number of ones in my given data is even, my parity bit is going to be 0. If number of ones in my given data is odd, then my parity bit is going to be 1. It's a basic rule for an even parity, that even parity can be either 0 or it is going to be 1 when based upon the number of ones in the data transmitted in my data should be even always. Now when number of ones in my given data is even, I am placing my parity bit to be 0. When number of ones in the given data is odd, then I am placing my parity bit as 1. Now for example, if I am having a number called 1110, then my parity bit is going to be 1. Why? Because the number of ones in my given bit of streams is 3, that is odd. So that's the reason I am choosing my parity bit as 1. Now if I am having the given stream of bits as 0110, that is I am having even number of ones in my given bit, that is 2. So I am going to choose my parity bit to be 0 for even type of parity. This is what related to even parity. Now the same situation will be explained for odd parity. Why? Because I am having two things. I am having even parity case and also I am having odd parity case. Let's check with odd parity. Now odd parity bit is 1 if in given stream of bits the number of ones are even. Means if I am having even number of ones in my given bit of strings, I am going to place my parity bit as 1. But for odd parity, the bit is going to be 0 if given bit of strings the number of ones are odd. Means if I am having odd number of ones in my given bit of strings, then I am going to place my parity bit as 0. Now if you observe clearly, this is my data stream which I am sending to through the transmitter. So if you observe clearly, the number of ones in my given bit of streams are 2, that is even number. So I am adding a parity bit as 1 for my data. Now coming to my second thing, the given bit of streams, the number of ones in my data is 1, single one. So for this one, I am adding 0 as my parity bit. Why? Because the number of ones in my given bit of data of stream contains odd number of ones. So that's the reason I am adding my parity bit as 0. So this is how you are going to add parity bits. Let us have one more example for odd parity. For example, if I am having 1100 as my data stream, so it contains even number of ones, that is 2. So I'm going to add my odd parity bit as 1. If I'm having 100, so I'm having even odd number of ones in my data stream. So I'm going to add 0 as my parity bit for odd parity. So this is how you are going to add a even parity or odd parity for a given bit of streams. Let's get into the next thing. That is how a parity bit can be generated. Now if you observe, I'm constructing a 3-bit even parity generator now. How to construct a 3-bit even parity generator? Let's see now. Now I'm taking 3-bit of information. For example, if I'm having the values 0, that is I'm going to represent 0, 1, 2, 3, 4, 5, 6 and 7. These are my given numbers. These are my decimal numbers which are represented in the form of 3-bit of information from 0 to 7, everything. Now I need to generate a 3-bit even parity. Means I need to design a circuit which is going to generate all my even parities for my bit streams from 0 to 7. Now if you observe 0, 0, 0 means there are no odd or even number of ones. So I am taking my parity bit as 0 here. Next 0, 0, 1 means odd number of ones. So I am adding my parity bit as 1. Next 0, 1, 0. I am adding my parity bit as 1. Why? Because only single one is there. Next 0, 1, 1 means 2 ones are there. So I am adding my parity bit to be 0 as output. Next 1, 0, 0. Only single one. So I am adding parity bit as 1 so that it becomes totally number of ones as even. Next 1, 0, 1. 2 ones are there. So my parity bit will be 0. Next 1, 1, 0. My parity bit will be 0. Next 1, 1, 1. My parity bit will be 1. Why? Because to make even number of ones. Why? Because I'm designing a even parity generator. Now you got these output values for a even parity. Let's map all these ones onto my K map. Now my 3 input variables are A, B and C. Now my output variable as Y. So for a K map, for simplification, this is my output variable. My input variables as A and BC. A takes either 0 or 1 value. B can take either go for 0, 0, 0, 1, 1, 1 and 1, 0. Done? So I am going to map all ones which are there at the output level onto my K map. If I am mapping my ones, now if you see 0, 0, 1 as 1, means 0, 0, 1. So I am mapping this here. Next 0, 1, 0, 0, 1, 0. So this is the second one. Next 1, 0, 0 is 1. So 1, 0, 0, 1. Next the last one, 1, 1, 1. So all ones, this I have mapped. Now if you observe K map clearly, I am not able to make any quad or a pair based upon these adjacent ones. There are no adjacent ones actually existing in my K map. So my possibility is to take only isolated ones to be selected on my K map. So I am selecting all isolated ones on my K map. Now when I take or write the expression for these ones, my expression is going to be like P is or my output variable is Y, not P. When my output variable is Y. Now when I am writing output Y as for these isolated ones, I am going to get it as A bar B bar C plus A bar B C bar plus A B bar C bar plus A B C. Now for this thing, I am going to take, you observe clearly, I am taking A bar common from first 2 terms. From this one and this one I am taking A bar common. So it becomes B bar C plus B C bar. Next 2 terms I am taking A common. So this becomes B bar C bar plus B C. Now A bar of B exclusive C. This is exclusive OR operation between B and C. Now this is B exclusive C, that is B XNOR C. So I am writing B exclusive C whole bar. Now again this is in the form of A bar B and A B bar. So what I am taking, A exclusive B exclusive C is my required operation. So this is what the equation which is telling me a 3-bit even parity generator can be utilized using this particular Boolean expression. Now let us see how I can map this particular expression onto gates. Now this is the diagram which is going to tell me what is the actual generator, how it is going to generate the 3-bit even parity. Now I got my expression, that is y is equal to A exclusive, B exclusive, C as my output. Now for this thing I need to generate the output thing. The output thing is, now when I am providing my message signal, my stream of bits, like for example I am providing 0110 as my bit of streams as an input to my circuit. Now when I am providing these kind of inputs, first I am going to perform exclusive OR operation between A and B first. Now this is A exclusive B operation. Now this result should perform exclusive OR operation with C. So that is what here it is happening. A exclusive, B exclusive, C. Now all these 3 bits I am taking as an output line along with my parity. Means I need whatever the parity bit which is generated by this result should be added as parity bit at the output terminal. So everything is going to give me a message signal along with parity bit. Now this is the circuit which is indicating a 3-bit parity generator which is going to generate even parities for my 3-bit of information. Okay, let's see the same thing for 3-bit odd parity generator. Now this is 3-bit odd parity. Odd parity means the number of ones in the given circuit or the given bit of streams should be an odd number, or else I need to put my parity bit as 1. Now if you observe the same thing for 0, for 0, 1, 2, 3, 4, 5, 6 and 7. This is my numbers. Now for these numbers I am writing my parity. Now if you see, observe 0, 0, 0, there are no odd number of 1. So that's the reason my parity bit is 1. For 0, 0, 1, odd number 1 is there. So that's the reason I am putting my parity bit as 0. Next 0, 1, 0, odd number of 1. So parity bit is 0 again. Next for 0, 1, 1, even number of 1. So I am putting my parity bit as 1 again. 1, 0, 0, odd number of 1s are there. So my parity bit will be 0. Next 1, 0, 1, odd even number of 1s. So I am marking my parity bit to be 1. Next for 1, 1, 0, even number of 1s. So parity bit will be 1 again. 1, 1, 1, odd number of 1s are there. So my parity bit will be 0. Now I am mapping all these things onto my K-map. Now I am mapping, again I am getting all as isolated ones. You see, observe clearly, I am getting all as isolated ones. Now when I take all isolated ones into equation form, I am going to get it as this particular thing, that is P is equal to A exclusive, B exclusive, C whole bar. Means there is an XOR operation going between A, B and C. Now you can see I have directly drawn a exclusive NOR gate in between A and B. Again that exclusive NOR operation between C, which is generating a odd parity for my circuit. So this is the circuit which is going to tell me whether it is able to generate a odd parity at the output level or not. So based upon my output levels, I have designed a combinational circuit. Based upon this, the parity is getting generated. That parity will be added to my data stream. So this is what related to even parity or odd parity. Okay, we'll meet in the next class. Thank you.